All right, I have my Math 130s. Essentially, this is going to be homework alternate chapter 8, 9, part 3, which is going to cover problems 4 through 6. We're going to make a relationship between inverse functions and composite functions. Just to give you some insight to start, it's a little notation. For an inverse function, say you have a function f of x and it has an inverse function, its inverse will be referenced f inverse x, okay, this right here. And note that the -1 that you see right here is not an exponent, so f inverse of x is not equal to 1 over f of x, okay? Also note that all inverse functions are 1-to-1. Here's the notation for that: 1 with a one with a colon between, 1:1. 1-to-1 functions are functions that pass the horizontal line test. We'll talk about that in more detail a little bit later. If you're testing to see if a function, or sorry, let me restart that piece. If you're testing to see if a relation is a function, okay, then you would use the vertical line test. Okay. If you're testing to see if a function is 1-to-1, you use the horizontal line test. All right. And why don't we delve a little bit into that before we move to this next part, because I think the next part might be a little bit confusing if we don't. Okay, let me just put that down there for a moment. So just an example. Let's just say that we have this relation and it looks like this. Call that f of x. So it's a line, right? Remember, in order to be a function, each input x must only have one output associated with it. Let's call this x value a and call this y value b. Okay, so the point AB is on the graph of f of x. This line passes the vertical line test, so f of x is a function. Okay, vertical line test passed. Now, if you were trying to see if it's also 1-to-1, then what you're doing, you're seeing, does each output only correspond to one input as well? And what we can see here is that this output of B only corresponds to one input A. Okay. So yes, the key here is just to use the horizontal line test. Pass a horizontal line to this entire function. And if you never have an overlap, or your paper doesn't meet the function twice, then you do have a 1-to-1 function. Okay, what that means is the horizontal line test is passed, and that function f of x has an inverse function. Okay, let me save this picture to start. I'm going to erase this middle example and give you another one, just so you can see a slight difference. So let's draw another one out here. Let's say I have a function f of x, it's a parabola. Getting better at this. Okay, so is our function, is our at this point, we wouldn't know if it was a function until we passed it through the vertical line test. So is our relation f of x a function? And the answer is yes, because the vertical line test is passed. Okay, essentially, here's my a value, the input. When I move up, I only get one b value back. Okay, it's fine that over here, say this is negative a, and it gives you the same b value. That's okay, it's still a function. You just don't want a repeat of a or negative a between 2 points. So we have negative a, b, and a, b on the same plot. Okay, now is f of x 1-to-1? And the answer is no, not on its entire domain. Okay, you see how this b value has more than one the b value is an output. It has more than one input that associates with it. So it's not 1-to-1. Okay, so this would be one spot where the horizontal line test is failed. Horizontal line test is failed. Okay. Now later what we'll find is you can actually restrict your domain. So like I could say, well, I'm gonna make this piece of my function one portion, and that domain would be -∞ to 0. And then I'm gonna make this piece have the domain 0 to infinity. And then I have two different functions and both would be 1-to-1. But don't worry about that until you encounter it, okay? Let me save that. And then just one more thing to get your mind jogging. I'm not going to do the example so that I can continue and get through this particular group of lessons today. But I want you to think about a circle. Okay. So Q is a circle. A function is a circle, a 1-to-1 function. I want you guys to think about that. Actually draw out a circle, test the vertical line test, test the horizontal line test, and see what you get. Just so that you'll be able to check the answer is no to both. Okay. Okay, now that we have gone over that a little bit, let's go ahead and just move this out the way too, so we have some more room. Okay, and then let's move all this up. Uh-oh. Oh, come on, man. All these little technical glitches are so bothersome. Okay. There. Okay, so now some properties of functions that are 1-to-1. If function f of x is 1-to-1, it has an inverse function, which is f inverse of x. What we find is that the domain of f of x is actually equal to the range of f of x. And the range of f of x is, I think I said that wrong. Let me repeat and slow down. So the domain of f of x is equal to the range of f inverse x. Okay, that's what bullet point 1 is stating. I didn't even notice this part at first. What is going on here? Aha, okay. Okay, statement 2 here is stating that the range of f of x is equal to the domain of f inverse x. Okay, now what these two bullet points together are stating is that if the point AB is on your function f of x, then the point BA is on f inverse of x. Okay, so x and y values flip. And then this third bullet point is saying if you take f composite f inverse of x and f inverse composite f of x, they're both equivalent to the same thing if f and f inverse are actually inverse functions. They should be equal to x. Okay, go ahead and save a picture of that if you're going to need it. See if I saved this picture yet. Yeah, I'm going to have to go back. Okay. So let me go ahead and save. Let me stop share for a moment and then share with you the problems we'll be going over. And we'll do it on the whiteboard, I think. I think I'll have enough room here. It's fine. So question 4 is first. For each pair of functions f and g below, find f of g of x. Note that this right here is f composite g of x. And then they also want you to find g composite f of x. And then determine whether or not f and g are inverses of each other, okay? So you have f of x given here for a and g of x given here for a. So let's do part A first. Okay, let's do this in different colors. Let's keep f of x 1 over 6x and g of x 1 over 6x. Okay. So then first thing we're going to want to do is find f composite g of x, and then find g composite f of x. If they're inverses, they should both be equal to x. So we'll do it over here on this side. So f composite g of x is going to be the same as f of g of x Okay, so f stays the same. G of x is going to be 1 over 6x. And then 1 over 6x will become the input for x for function f. So for f, we have 1 over 6x, change x to 1 over 6x. And then simplify. So we have 1 on the top. On the bottom, we have 6 divided by 6x. That's 1 divided by, careful here, 6 is going to cancel 6, but you still have 1 over x left over. That turns into an old school division. That's 1 divided by 1 over x, which is 1 times x over 1, which is x. So we found out that f composite g of x, aka in this case, f of g of x is equal to x. Let's save that. And then let's look at the second part. Hopefully you're seeing for this one, it's going to be the same, just for slightly different reasons. So G composite f of x is equal to G of f of x, which is the same as G of f of x is 1 over 6x. So plug that in. Function g is 1 over 6 times x. X is 1 over 6x from function f. So that actually comes out to be exactly the same. So for the first part, f and g are indeed inverse functions. Okay. That's part A. Let's look at part B. Okay. So for part B, we have f of x as x plus 4, g of x as x plus 4. You want to test the composite. So f composite g of x, start there. It's going to be f of g of x. That's f of, you have x plus 4 as the function g of x. And then function f is x plus, x plus 4. But remember, your x will be replaced by x plus 4, the quantity from g of x. And you still have your ending plus 4. So you get x plus 4, that's x plus 8. So f of g of x is actually equal to x plus 8. So we already know that f and g will not be inverses of each other for this reason. Let's test part B. Let's just do it in the same color though, just black, because it's getting a little exhausting to change colors so much. So G G composite F of X. That's going to be G of F of X, which is going to be G of F of X here is X plus 4. And then G X plus 4. So it actually comes out to be the same. But it doesn't matter that they're exactly the same. What matters is that they're not both equal to X. If they're both equal to X, inverse functions. If they're not inverse functions. Okay. That is number 4. Let me save that. And then I'm going to go ahead and clear this out. This takes us to number 5 next. The one-to-one functions G and H are defined as follows. You have G. Let's make this one green, or sorry, orange. This is going to be a discrete function. And then H is a continuous function. So go back to maybe chapter 2 if you still need definitions for that, or you can just ask me. Okay, so discrete, we have a countable number of points in the set. Continuous, we have an infinite number of points in the set. We want to find the following. So it's a little bit different for a discrete versus continuous function. Let's call this part A, B, and C. For part A, we're looking for G inverse of 3. So what we need to remember is that if we had our original function, G of X, the question mark and the 3 would switch. Okay, so for the function G of X, we have this point question mark 3, okay? For G inverse X, the question mark and the 3 will switch. Okay. So what we're looking for here is, okay, we have G. So G inverse of X, and we can actually just leave the X off. We'll do it the same notation. G inverse, you would switch the X and Y values for all those points. You have 5, -7, 3, -2, 7, 3, and 9, 5 in that set. So this is what we're looking for right here. And the question mark is equal to -2. So a shortcut, look for where the Y value is equal to 3 in your function G. You'll look for the X value that corresponds. Let me save that, and then I'm going to clear this out. Your next bit is looking for H inverse of X. Oh, come on. Okay, so you have H of X already. There are some rules if you're trying to find an inverse function. from an equation. Okay, so one, you're going to change the function to y. So in this case, we have h of x. We're going to change h of x to y. Keep the rest of the equation. 2, you're going to switch x and y. So switch x and y. Don't change anything else. You're just changing the literal x and y. And lastly, well, second to lastly, you're going to solve for y. So in this case, x minus 9 equals 2y. So x minus 9 divided by 2 is equal to y. Okay. So y equals x minus 9 over 2. And then the last step, change y to inverse notation. I say that because sometimes it's an f for your function, sometimes it's an h, sometimes it's g. In this case, we had h of x. So now we're going to have h inverse of x replace y. So our inverse here is going to be x minus 9, the quantity divided by 2. Okay, let me save that. Okay. All right, let's save and then clear out a bunch of this. Moving on to part C. Part C asks you to find h inverse composite h of -2. Now you will save yourself a bunch of time if you remember that rule. Recall, if h and h inverse are actually inverse functions, and we know that these ones are because we just found the inverse formally. Then h composite h inverse of x will be equal to x, and h inverse composite h of x will be equal to x. So h inverse composite h of x should be equal to x. Same number. Otherwise, you have to plug it in and find the composite, and that's a lot more work. Okay. All right, let me clear this out and then I will get into question 6. And then I will end this video. Okay, question 6, the one-to-one function h is defined below. Find h inverse of x, where h inverse is the inverse of h. Also state the domain and range. We'll use different colors for those. Domain and range of h inverse in interval notation. Okay, so first thing to remember, actually, let's just find H inverse first. That's the best thing. Okay, so that's going to follow our same steps. Okay, so the first thing, we're going to change H of X into Y. Okay, then we're going to switch X and Y. So everywhere we see Y, we put X, and everywhere we see X, we put Y. And then we're going to solve for Y, which might be a little tedious in this case. Multiply both sides by 5y plus 7, the quantity. Distribute out. Combine your y terms on one side and your terms without y on the other side. Factor y out. And then divide both sides by 5x minus 8, the quantity. Okay. That is our inverse function. So the last step, change that to H inverse X. All right, so check for the first part. Save the picture. I'm going to take this portion and move it up to the top so we can remember that. And then we're going to find the domain and range. Okay, so this part's a little bit abstract, right? First thing to remember is, I'm trying to think of the easiest way, the way that you guys will probably think about this. Let's just start here. We'll start with the domain. Of H inverse X, because you already have a function for H inverse, right? So the domain comes from the denominator or the root rules. We see that our denominator is 5x minus 8. And remember, we want to set that not equal to 0. And then we're going to solve back for x. So 5x cannot equal 8. And x cannot equal 8 over 5. Okay, so let's put the domain down here for H inverse X. Oh, no. Okay, so the domain in interval notation, remember we're saying here that 8 over 5 is the only value we can't touch. Everything else is okay. So negative infinity to 8/5, union 8/5 to infinity, don't include any of the boundary values. For the range, this is where it gets a little weird. Remember, the range of H inverse of X is the same as the domain of H of X. So what you're going to want to do to find the range for H inverse, you want to actually look at the denominator from H of X. set that not equal to 0 and solve back for x. 5x cannot equal -7, and x cannot equal -7/5. Here's your number line of x values. -7/5 is off limits. Everything else is okay. So we have negative infinity to -7/5, parenthesis, parenthesis, union -7/5 to infinity. Okay. Let me save that. And then I think I will leave it at that for right now. I will do a whole brand new Zoom for questions 7 and on. So I will post these as parts 1, 2, and 3, the videos that I've gone over so far. And I will send you guys a message when it's up. All right, thanks for joining me. Let me know what you think and if you have any questions.